Now we're going to finish for the week talking about combinations, which are what occur when we make selections very similar to permutations. We're selecting without repetition, but order does not matter. So let's go back to think about that race example from the previous section, where if we make that race the Olympic trial, and instead of trying to see who comes in first and second, we want to pick a certain number of racers to sponsor. If we're doing it before the race is run, the order in which they're selected really doesn't matter, because there's no real organization in there, especially if we're giving them the same sponsorship. So how we pick those two doesn't really make a difference. We're just selecting two of them. And if we do a selection in that way, if we're making a selection of R things from N, we say that's something to the effect of N choose R, where order does not matter, we denote it using combination notation NCR or C parenthesis N comma R, or sometimes even N over R in big parenthesis. You may see this later depending on where you go. But long and short of it is, when we're dealing with this notation, we have N factorial total options, the total number of things. In this case, we're going to talk about the race. We could say we have 8 choose 2, where that would be 8 factorial total options. And then on the bottom, we have N minus R for the rest of the things that we don't care about. So in this case, it would be 8 minus 2 factorial. All the arrangements of them, we don't really care because we're only picking 2. And then because order doesn't matter, we also remove the arrangements for the specific things. It's like picking numbers from 1 to 5, where if I don't care about the order, 1, 2, and 2, 1 mean the same thing. So we've got to knock out 2 factorial cases as well here, which, up to a little bit of algebra, a little bit of simplification, would get us down to 8 times 7 over 2 factorial, or, if you prefer, 28. Or something that's very important to notice with combinations as compared to permutations is we get far fewer options when we deal with taking selections where order doesn't matter. That makes sense if you think about some other cases, that you can get a whole lot of numbers or a whole lot of selections that are the same thing up to reorganization. So we should get far fewer results if we don't care about order. And in this case in particular, if we think about that in that way and we compare 8 choose 3 to 8 permute 3, or in this case 8 permute 2, I don't know why I said 3, but so it goes. I'll leave it to you to check this, but 8 permute 2 would be 56, which is certainly larger than the value 28 or 8 choose 2. We always have fewer options if order doesn't matter.